Assalamualaikum and a very good day to everyone. We are from Group 7 from class AS1202_1. Today we would like to present our Calculus 1 video project for Assessment 2 under the course MAT 183. This video presentation covers the topic techniques of differentiation. Now, let's meet the team. First, we have Nur Alia binti Ahmad Zamzam Azlan. Second, we have Nur Shaliza binti Jamaluddin. Hi! Third, we have Dania Atira binti Muhammad Hazuri. Fourth, we have Nur Syafiqah Frina binti Ahmad Muhibbuddin. And last but not least, we have Nur Syafira binti Muhammad Azmi. Now, our presentation will begin with question 1, which is explain the meaning of differentiation and what are the technique of differentiation. Differentiation is one of the most important concepts in calculus. It's focusing on determining the rate at which a quantity changes. Mathematically, to differentiate a function means to find its derivative. In simple word, differentiation is process of finding the rate of change. The derivative of a function fx with respect to x is written as f prime x or dy over dx. This represents the slope of the tangent line to the curve at any point on the function. This concept is widely used in real life, such as in physics to study motion, in economics to find marginal cost, and even in biology to analyze growth. There are several techniques that we use to differentiate different types of function. First, we have power rule. This used to differentiate power of x. Second, we have constant rule, which means the derivative of any constant is 0. Third, we have product rule. This used to differentiate two functions multiplied together. Next, we have quotient rule. This used when dividing two functions. Next, we have chain rule. This used for composite function, which is function inside the functions. Not only that, we also have constant multiply rule, which means a constant multiplied by a function stay outside during differentiation. Last but not least, sum and different rule. This means differentiate is termed separately in a sum or different.
Now let's move on to question 2a. The question is find dy over dx for the following function 3x squared secant in bracket x plus 2. I figured that we can get the final answer by using the product rule formula. The formula is dy over dx equal to uv prime plus vu prime. First we let u as 3x squared and v as secant in bracket x plus 2. Next we find the u prime, which is 6x, and v prime as secant in bracket x plus 2, tangent in bracket x plus 2. So now we add all of that in the formula and we get it as 3x squared secant in bracket x plus 2, tangent in bracket x plus 2, plus secant in bracket x plus 2, 6x. We rearrange and we get it as 3x squared secant in bracket x plus 2, tangent in bracket x plus 2, plus 6x secant in bracket x plus 2. I figured that we can simplify this answer by taking x secant in bracket x plus 2 out and we put square bracket and we put 3x squared tangent in bracket x plus 2 plus 6x another square bracket. We can simplify this again by taking out 3x and we get it as 3x secant in bracket x plus 2 square bracket 2 plus x tangent in bracket x plus 2 square bracket.
So let's move to question 2b. So the given problem is find dy over dx for the following functions of y equal to 4x plus 2 over cos x. So what exactly is dy over dx and what does it want us to do? So dy over dx is derivative and it tells us how y changes with respect to x. So in this problem, the first thing that we have to do to solve this problem is to identify what is the structure of the function. As for this is the quotient. Why? Because it is a function that is divided by another. As you can see, at the top we have 4x plus 2 and at the bottom we have cos x. So we're gonna use the quotient rule to solve this problem. With its formula, dy over dx equal to vu prime minus uv prime over v power of 2. So we're gonna identify what is the u, the v, u prime and v prime. So we're gonna take the top one, which is 4x plus 2 as the u and the bottom cos x as v. So how to find its prime? To find its prime, we have to differentiate it. So we have to differentiate 4x plus 2. So we got u prime as 4. And then in the v, we have to differentiate it and we got negative sin x as the v prime. Now that we are complete, let's just plug them into the formula. As you can see, dy over dx equal to cos x in the bracket, 4 in the bracket minus 4x plus 2 in the bracket and negative sin x in the bracket over cos power of 2x. And then you will get 4 cos x plus 4x sin x plus 2 sin x over cos power of 2x. We can simplify it and we got dy over dx equal to 4 cos x plus 4x plus 2 in the bracket sin x over cos power of 2x as the final answer for the derivative. Notice that the structure of the final answer for derivative, we can solve it using the trigonometric function. Let's flash back to MAT 133 that we have learned in semester 1 in the topic of trigonometric function. So we will get the final answer is 4 secant x plus 4x plus 2 in a bracket tan x secant x. And now we are done.
So the question given is y is now in the bracket of 3x minus e to the power of 2x plus 1 minus tan 4y equal to 0. And it was stated there that we need to find dy over dx by using implicit differentiation. And as you can see, that's the answer for the question provided with the appropriate step. So now I will be explaining the step one by one. Firstly, we write back the equation y ln in the bracket of 3x minus e to the power of 2x plus 1 minus tan 4y equal to 0. So we have to differentiate the equation. Before we do that, we write all the equation as d over dx y ln in the bracket of 3x minus d over dx e to the power of 2x plus 1 minus d over dx tan 4y equal to 0. So we separate it into 3 parts to make it easier. So firstly, we differentiate d over dx y ln in the bracket of 3x. So to differentiate d over dx y ln in the bracket of 3x, we have to use product rule, which is u v prime plus v u prime. So firstly, we let u equal to y, u prime equal to dy over dx, v equal to ln in the bracket of 3x, v prime equal to 1 over 3x times 3, and the answer for v prime equals to 3 over 3x. So the answer for d over dx y ln in the bracket of 3x equal to, we substitute back the answer, which is the answer for u is y, v prime is 3 over 3x plus the answer for v is ln in the bracket of 3x times u prime is dy over dx, and then we simplify it and it will become y over x plus ln in the bracket of 3x times dy over dx. Next, we proceed to the second part, which is differentiate d over dx e to the power of 2x plus 1. To differentiate this one, we have to write back e to the power of 2x plus 1 times d over dx in the bracket of 2x plus 1, and then it will become e 2x plus 1 times 2, and the answer is 2e to the power of 2x plus 1. And we proceed to the last part to differentiate, which is d over dx tan 4y. Tan is actually secant square, so tan for y equals secant square for y times d over dx for y, and then secant square for y times 4 dy over dx. So how we get dy over dx is from the differentiate of y, and then the answer that we get is 4 secant square in the bracket of 4y and in the bracket of dy over dx. Next, we substitute back all the answer back into the equation, which is d over dx y ln in the bracket of 3x minus d over dx e to the power of 2x plus 1 minus d over dx tan 4y equal to 0. We substitute d over dx y ln 3 in the bracket of 3x, which is y over x plus ln in the bracket of 3x times dy over dx minus answer of d over dx e to the power of 2x plus 1, which is 2e to the power of 2x plus 1 minus the answer of t over dx tan 4y, which is we get 4 secant square in the bracket of 4y and in the bracket of dy over dx equal to 0. Next, we combine ln in the bracket of 3x minus 4 secant square in the bracket of 4y. How we have to combine is, first, we open bracket, put ln in the bracket of 3x minus 4 secant square in the bracket 4y close bracket times dy over dx equal 2e to the power of 2x plus 1 minus y over x. We remove 2e to x plus 1 and y over x from the other side to the other side, and then we get dy over dx equal to 2e to x plus 1 minus y over x, and we put over ln in the bracket of 3x minus 4 secant square to the bracket of 4y, and that's the answer for this question.
Alright, for the question 4, it says that use linear approximation to estimate the value of root 4 of 80.99 minus 2 over square root of 80.99. Correct to the 3 decimal places. Okay, let's remember back. The linear approximation formula is fs approximately equal to fa plus f prime a times with delta s. Given from the question, we can find that fx is equal to root 4 of 80.99 minus 2 over square root of 80.99. Okay, because we cannot solve the equation directly, we need to use some variable. So let's assume that 80.99 is equal to x. So we can find that fx is equal to root 4 of x minus 2 over square root s. We can solve this and it becomes to x power of 1 over 4 minus 2x power of negative 1 over 2. Next, we need to find the f prime s. So f prime s is equal to 1 over 4 power of negative 3 over 4 plus x power of 3 x power of negative 3 over 2. After that, we need to find the delta s. Okay, remember that delta s is equal to x, which is the given value, minus a, which is the new given value from the question. So from our question, delta s is equal to s minus a, which is 80.99 minus 81. Because let's assume that the approximately 80.99 is hampir to 81. So from that, delta s we've got equal to negative 0.01. After all that, we need to find the fa and f prime a, which is a is the new value that we computed approximately equal near to the given value. So our a is equal to 81, right? So our fa, which is f 81, equal to root 4 of 81 minus 2 over square root of 81. After calculating all of that, we got the value of f 81 equal to 2.7778. Okay, next we find the f prime a, which is equal to f prime 81 equal to 1 over 4 times 81 power of negative 3 over 4 plus 81 power of negative 3 over 2, and calculate all that, we got 0.01062. After that, we we can replace all of the calculated value into the original formula. So f 80.99 equal to f 81 plus f prime 91 times negative 0.01, which given us f 80.99 equal to 2.778. That is our final answer.